This is question 1. Let p x equals to k equals to b times k times p to power k minus 1. K equals to 2 equals to 1 to infinite, and the p is bigger than 0 and smaller than 1. So far for part A, find B so that p x equals to k represents the probability mass function. So for the step for the first step, we need to use cumulative the px equals to k, and then we can organize this to b times d derivative limited p times 1 minus p to power k over 1 minus p, and the result is b times d over derivative times p over 1 minus p times 1 over 1 minus p to power 2, because it should be probability mass function. So the result needs to be equal to 1. So b equals to 1 minus p to power 2. For the part B, find Ex. Ex can be equal to cumulative k times p, x equals to k, and equals to 1 minus p to power 2 times cumulative of k squared times p to power k minus 1, and then we can get the results 1 plus b or 1 plus p over 1 minus p. For part C, find the Ex squared. It should be cumulative for k squared times p x equals to k, and then we can use 1 minus p squared times cumulative of k cubed times p k to power k minus 1. So we can get the results p squared plus 4p plus 1 over 1 minus p squared. For part D, find Ex squared minus E squared x. So we can see the formula is part C minus part B squared. So it should be p squared plus 4p plus 1 over 1 minus p squared minus 1 plus p over 1 minus p squared equals to 2p over 1 minus p squared. So for part E, let P equals to 1 over 3. Find the conditional probability mass function P x equals k. X should be larger than 2 and smaller than 5. So B equals to 1 minus P squared. It should be 1 minus 1 over 3 squared time equals to 4 over 9. And we want to find the conditional probability mass function. It should be 1 over 0.538 times 4 over 9 times k times 1 over 3 to power k minus 1 when k equals to 2, 3, 4, 5. And otherwise the formula should be 0.